Oh, hello, Yanan. Welcome to your homework feedback video session for the third homework of the year on physics energy. Make sure you have a green pen. Make sure you write down the correct answer to the question you go wrong. And make sure you bring your homework back on the right day at the right time. Let's begin. Each letter A, B, C, D, and E represent an energy transformation. Write the correct letter for each device. So a fan, the idea of the fan is to generate wind by turning a motor, okay, which is going to create fan. So we need to turn electrical energy into kinetic energy. Movement is kinetic always. So C, electrical to kinetic. A kettle, we want to generate heat, or we want to start filling up the thermal energy store of the kettle. So it's going to be electrical to heat or to thermal energy store B. A lamp is used in order to make light. Size D, electrical to light. A radio is used to generate sound. There's going to be E. C, B, D, E are the answers you had to give to get 4 marks out of 4. Next, person using a leaf blower to move some leaves. The leaf blower is powered by an electrical motor connected to a battery. Energy transfers take place when the leaf blower is being used. So the battery stores chemical energy, which is transferred into electrical energy. This is very important to remember. A battery, food, or fuel, or all stuff like that are chemical potential energy store. Okay, you need a chemical reaction to take place, and that's going to release energy to the surrounding. So in that case, it's going to release chemical energy. The energy is kept as chemical energy is going to be transferred electrically. And then the electric motor is going to transfer the electrical energy into kinetic energy. Okay, it's going to generate some wind or pushing air, which is going to create movement, which is kinetic energy. And then the motor is going to waste energy as sound energy and as energy that hits the surrounding. So the idea of the leaf blower is just to create kinetic energy. You just want to move the leaves, okay? The sound and the heat produced at the same time are wasted energy. You don't want it to happen, but it does happen. Then 4 students are talking about the different energy sources used to generate electricity in the areas where they live. The first one, live in the sunniest part of the country. So the energy source is probably going to be solar panels or solar. The second one, live in a land that's very flat and it always seems to be windy. They're going to use the wind energy. The third one, live in a place where it's not safe to swim because the sea is always too rough. So that's probably going to use waves energy. And finally, where I live, you can see steam coming out of the ground. That means that the underground is very hot. Probably it's usually close to areas where we have volcanoes or seismic activity. And that can be used to heat up water. And that is called geothermal. So if you look at geothermal, it means the earth, and thermal is a reference to the heat energy. So those were the 4 marks you could get with these 4 energy sources. What do all these energy sources have in common? They're all renewable. Okay, you're never going to get rid of the wind, of solar, of tides, waves, and geothermal. In a hydroelectric power station, the energy from falling water is used to generate electricity. Which one of the following gives a disadvantage of a hydroelectric power station? So to build a hydroelectric power station, you need to create a dam to kind of like trap water in a lake and then open some sort of like little river in the dam that's going to make the turbine turn. So the problem with that, the disadvantage is that it's going to flood large areas of land. So that's the correct answer. Hydroelectric power stations do have a fast startup time, but that is not a disadvantage. That is pretty good. It means like whenever you need electricity, you can just start it straight away and you're going to generate electricity immediately. Some other power stations are going to take a lot more time to generate electricity or to start proper. As for polluting gases are produced, that is not the case. The water is just flowing down, making the turbine turn. That is not going to generate any sort of polluting gases. So the correct answer was the second one. Next, beautiful picture. Yours is better on your worksheet, I hope. It's a solar-powered aircraft that doesn't have a pilot. The solar cells are designed to transform light energy from the sun into electrical energy. And this electrical energy is then going to be used and be converted into kinetic energy to make the plane move forward. Next question. On a summer day, 175,000 joules of energy are supplied to the aircraft's solar cells every second. That is a lot. The useful energy transferred by the solar cells is 35,000 joules every second. Okay, so out of these 175,000 joules, 35,000 are used efficiently. The formula for efficiency is given here. So to calculate it, you're going to divide 35,000, which is the useful energy transferred by the device, divided by the total energy supplied to the device. Both of them have to be in the same unit. It's the case here. It's all measured in joules. And if you do 35,000 divided by 175,000, you should find 0.2. So that is the efficiency, 0.2. Sometime you may be asked to give an efficiency in percentage. So you just have to multiply this value by 100, and it will give you 20% efficiency. The aircraft propellers are driven by electric motors. Give one environmental advantage of using electric motors to drive the aircraft propellers rather than motors that burn fuel. Environmental means that you are not going to produce any greenhouse gas, such as carbon dioxide, which is good. That's going to prevent a little bit of global warming. There is no sound or less sound being produced, and there is less demand for fossil fuels. Okay, but does not produce the greenhouse gases is kind of like the common answer for all your exam questions. Next, question 5. A student investigated how the number of blades on a wind turbine affects the output voltage of the turbine. So the number of blades is the independent variable, is the one they change on purpose, and what they're measuring is the output voltage that they're measuring with the voltmeter. The fan was used to turn the wind turbine. The fan was always the same distance from the wind turbine. Okay, so that's something you need to keep the same to make it a fair test. It's a control variable, because if you change the distance, that would affect the voltmeter reading. Okay, there is a chance that if you put the fan a lot closer to the wind turbine might turn faster. That would generate a higher voltage or higher potential difference. So you want to keep the distance the same to make it a fair test. After switching the fan on, the students waited 20 seconds before taking the voltmeter reading. Why? So it's for the fan to reach a steady speed, or for the wind turbine to reach a steady speed. It could also be for the voltmeter to have a steady reading. Okay, so you just want to, because when you start, a fan always starts slowly and then accelerate. So you want it to be at full speed. Same with your wind turbine. You want it to reach its maximum speed and constant speed to read and to make it a fair test. The students change the number of blades on the wind turbine. The students' results are shown in the scatter graph below. Okay, what conclusion can be made from the results in the scatter graph? So you can see that between 1 and 4, if you increase the number of blades, you increase the output voltage in volts. Okay, so that could be a first conclusion. As the number of blades increases, so does the output voltage. That's for 1 mark. For between 0 and 3, this is directly proportional because you have a perfectly straight line starting at the origin. That is valid only up to 3 blades. And you can see that after 4 blades, adding a new blade almost makes no difference to the voltage reading. Okay, so the first one has to be there. The number of blades increase, so does the output voltage, 1 mark. Then you can say the increase is directly proportional up to 3 blades for a second mark. Or for the second mark, you can also say the voltage almost reaches a plateau after 4 blades. The amount of electricity generated using wind turbines is increasing. Which graph A, B, or C is most likely to show the electrical power output from a wind turbine over 1 day? It has to be graph C, okay? And that is because the wind speed varies during the day. Okay, graph A would mean that the wind is constant, always blowing at the same speed. Graph B means it would have wind, then no wind, then wind, then no wind, then wind, but always with the same value, almost impossible. Graph C is more realistic. It's going to go up and down with the law of variation. And finally, a small group of people live in an area in the mountain. The people plan to buy an electricity generating system that uses either the wind or the flowing water in a nearby river. So they give you ideas about the cost and the general output. And you have to compare the advantages and disadvantages of the 2 methods of generating electricity using your knowledge of energy resources and the information given. So the advantage of both methods, because you have to compare, you have to talk about both methods. They're both renewable sources of energy. They both have no fuel, so that is a lot cheaper than burning fossil fuel, and no carbon dioxide is produced. The advantage of wind compared to hydroelectric, it has a higher energy output, okay? 10 kilowatt for the wind, only 8 kilowatt for the hydroelectric generator. The advantage of hydroelectric is that it's constant and reliable power. Okay, the river is almost always going to be there. It has a lower installation cost, only £20,000 for the hydroelectric and £50,000 for the wind turbine. The disadvantage of wind is the higher installation cost or a variable and reliable power output. Okay, the wind, it's pretty much inconsistent. It can be very windy one day, very unwindy the other day. The disadvantage of hydroelectric is the lower power output. And for both methods, the disadvantage could be they may be noisy or they can generate visual pollution. Right, so about the 6 marker, pretty much. You had to compare, so give advantage of both and disadvantage of both to get your 6 mark. Okay, I'm going to leave that here. Please make sure you have write down a proper, nice answer with your green pen for this one. Okay, this is it for me. Code at the end. Can you draw a fish at the back of your test to prove that you've watched the entire video? Okay, this is officially now it for me. Have a beautiful day. Stay amazing, and I will talk to you very soon. Bye-bye.